Okay, so we have this problem from IA Maron. Says prove that if for an exponential function y equals a to the power x, where a greater than 0 and a not equal to 1, the values of the argument x equals to n equals 1, 2, 3 forms an arithmetic progression, then the corresponding values of the function yn ax to the power a to the power xn is from a geometric progression. So let's dive into this problem. Basically, what we have here is x equals to xn and goes 1, 2, 3, and so on. So basically, this it says this is an AP. So this means that x1, x2, x3, dot 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 is an AP. And therefore, we can write x2 equals to x1 plus d, and then x3 equals to x1 plus 2d, and so on. So, and then we have to prove it for yn equals to ax to the power n. So therefore, what I'll do is I'm going to write y1 is equals to a to the power x1, y2 will be a to the power x2. Now, from here we can write y2 equals to a to the power x1 plus d from here. So let's name this equation. Now therefore we can further write this as x1 dot a to the power t. Okay, now once again, if we write y3, we'll get ax to the power ax3, a to the power x3. Now this can also be written as a to the power x1 plus 2d. This is from equation 2. This is from 2. Now we can write this as a x1 dot a to the power 2d. Right. So now if we compare y1, y2, and y3, we have a to the power x1, a to the power x1 dot a to the power d, and a to the power x1 dot a to the power 2d. So basically, as you can see, y2 by y1 is a to the power x1 times a to the power d by a to the power x1, which is a to the power d. Again, y3 by y2 is a x1 to the power 2d by a x1 a to the power t, which is again a to the power t. So we are having a common ratio a to the power d. Therefore, we can write therefore y1, y2, y3 a gp. with common ratio a to the power d. And as we get to prove, yn a to the power xn is a geometric progression. Therefore yn to the power xn for gp. Hence proved. So that's it. That's the solution. Thank you for watching.